Now we're going to take a step further and try to convert moles into molecules, number of molecules and the mass, okay, of a molecule instead of just an atom. So let's start with our first problem, and the first problem is calculate the number of formula units of calcium carbonate in 1.28 grams of calcium carbonate. Now remember, I've said to you before, you have to know your nomenclature well, which means that you should know that calcium carbonate is CaCO3. Okay, our first strategy is to find out the weight of calcium carbonate, because for a formula unit you need to find out the mass, okay, of calcium carbonate. So that's what you do first. So you have 1 times calcium, 1 times carbon, and then 3 times oxygen. So 1 times calcium, that is 1 times 40.08, and then carbon is 1 times 12.01, and then oxygen is going to be 3 times 16.00, and I'll just round that off to 16.00. It's 15.99999. So anyhow, so 40.08, 12.01, and then 48.00. By the time you do all the addition and everything, it should come out to be 100.09 grams per mole of calcium carbonate. Okay, so that's your mass. Our strategy for this kind of a calculation, where you need formula units, is to go from grams to moles to formula unit. Remember, we decided that before also, that you have to go through the moles. Okay, and because we needed to go through moles, that's why we calculated the formula mass. Okay, and so grams, we have 1.28 grams of calcium carbonate. I would suggest you always write the formula there, and then convert the grams calcium carbonate to moles of calcium carbonate, and then from moles we will go to formula units, and I will just write that as, well, formula unit. Okay, a little bit short. And so in 1 mole of calcium carbonate, we just calculated, we have 100.09. I'm not going to round off right now, I will do that towards the end. Okay, in 1 mole of calcium carbonate, we have 6.022 10 to the power of 23 formula units. That number does not change. So it could be anything. It could be moles, it could be molecules. So in this case, it's a formula unit, and it's formula unit because it's an ionic compound. Okay, and so grams, grams, moles, moles. You're left with formula units. By the time you finish this whole calculation, you should come up with 7.702 10 to the power of 21 formula units, which then you can round off to 7.70 times 10 to the power 21. Okay, formula units. And that's your answer then. Let's take a little bit different problem now. I'm going to take it one step further. And so now we are going to calculate the number of sodium ions in 1.28 grams of sodium hydrogen carbonate. Again, nomenclature. Okay, so you have to know that. And so you know that sodium hydrogen carbonate is NaHCO3. Okay, that is sodium hydrogen carbonate. Let me write our strategy first, okay, so that you know where we are going with this. You're supposed to calculate the number of sodium ions in 1.28 grams of sodium hydrogen carbonate. This is the only number that's given to you. So which means we have to go from from grams to moles. Now what grams? We have to go from grams of NaHCO3, sodium bicarbonate, to moles of sodium hydrogen carbonate, and then we'll find out moles of the sodium ions that we have in the moles of sodium hydrogen carbonate, and then we will go to ions. okay, of sodium. That's our strategy. So let's start that. First of all, by the way, we need to calculate the mass, okay, of sodium hydrogen carbonate, and that is 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. And you can do that calculation yourself, and hopefully you will come out to have 83.318 grams per mole. Okay, that is the mass of NaHCO3. Okay, so you can do the calculation yourself. So starting with 1.28 grams of sodium hydrogen carbonate. As I said, always write the chemicals out so you know what you're dealing with. To convert it to moles, you need to have moles on the top, NaHCO3, and grams of sodium hydrogen carbonate down here. And then you need to convert it into moles of sodium hydrogen carbonate. So which means that moles of sodium hydrogen carbonate goes down here, and moles of sodium ions goes up here. And then the last calculation is moles of sodium ions to ions of sodium. Okay, and so let's put in the numbers and see if it makes any sense. So the grams of sodium hydrogen carbonate is the mass, which is 83.318 grams in 1 mole of sodium hydrogen carbonate. In every 1 mole of sodium hydrogen carbonate, we have 1 mole of sodium ions, okay, and that comes from the formula. And then in 1 mole of sodium ion, there are 6.022 times 10 to the power of 23 ions. And then you do the calculation. Okay, so make sure you cross out your units so you know that you're left with what you need, okay, which is the ions of sodium. And hopefully your final answer will come out to be 9.25 times 10 to the power of 21 sodium ions. That's your final answer. So in this case, if we were calculating for oxygen, then there would be 3 moles of oxygen. Okay, in this part there will be 3 moles of oxygen for every mole of sodium hydrogen carbonate. Okay, that's the mole ratio here.